Hello friends, welcome to this video. In this video, I am going to talk about some calculations that you have been requesting from a very quite long period of time. So sorry for the delay, and also many people have requested to slow down my video editing process because you are not able to catch up the speed. So what I am going to do, since it's bit lengthy, I am going to divide it into two parts. In the first part of this video, we are going to talk about the basic calculation, stock preparation and all those things, and molecular weight calculation of the solid compounds and all. In the second video, we are going to second part of the video of the calculations, we are going to talk about the calculation part for the liquid. So there is some differences in that, so I have taken that in the second part of the video. So without much delay, we will proceed to this video. In this video, first we'll talk about the stock preparations and all. So when it comes to the calculations, say as a biologist, including me, in the initial stages we face a lot of difficulty in calculating, in knowing what is molecular weight, what is molarity, normality, how do we prepare stock. In no papers, if you are especially doing a research, no papers will show you how to calculate. And also with practice, with time, you become, and after some time you get used to the calculation and you develop that confidence. So initially we have to practice a lot and we have to do it on our own. So now let me start with the stock preparation. So many people, let it be even for your biochemical assays or for the tissue culture, we need to prepare a lot of stock. So, and all the stock preparation or even solvent extraction, methanolic extract preparation, even there we prepare stock of the plant extract. So many people have asked me what is the ideal concentration, how do we prepare all those things. See, there is nothing like ideal concentration or ideal stock preparation, or there is nothing universal. It is left to the compounds that we have, the quantity that we have, the rate over it. If some stocks are very expensive, we will take lesser stocks we will prepare. So it all differs with the availability of the compounds and the storage and how much we require, that's all. So now let us go to, without delay, we will move to the stock preparation. So as the name says, stock is something from which we regularly take and we use. Every time we cannot keep on preparing the chemical, so we prepare stock and keep. We just prepare that, dilute it to the required volume, and we can carry our experiment. So an ideal stock solution is not, it's nothing like ideal. So out of my own things, the way that I prepare, I am saying you that we prepare a stock, for example, hormones, if I am giving an example, we prepare a stock of 1 mg per ml. See, 1 mg per ml means if I take 1 ml of solvent, I add 1 milligram of the solid or whatever compound is it. So I hope you will know the conversions from milligrams to grams and all, or from micrograms to milligrams and grams, because that is very much required, because I cannot weigh a compound in milligrams. All our weighing balance are calibrated or equivalent in grams. So for those who don't know, 1 gram is equals to 1000 milligrams. So I can write it as 10 to the power of minus 3. Similarly, 1 gram is equal to 10 to the power of minus 6 micrograms. So or I can write it as 1 milligram is equals to 1000 microgram. Microgram comes as mu. So we write it like a U. So this represents micro. The U represents micrograms. Mu it is called as. So this is some of the ideal calculation that you need for conversion. So I hope this is fine. So up till micrograms only we calculate, we never go to nanograms and all. Nano is nothing but 10 to the power of minus 9. So we go only up to 10 to the power of minus 6. So you require this for conversions and all. Now moving on to this, we prepare a stock of 1 mg per ml. That means I take 1 milligram in 1 ml of solvent I take. That is one option I can give you. Or we can prepare a stock of 10 mg per ml. So this number you can, whichever is ideal to you or comfortable to you, you can choose 10 mg per ml. If you are preparing methanolic extracts and all, I prepared methanolic extracts of 10 mg per ml. So if you watch my videos on biochemical assays, it will be 10 mg per ml, the methanolic extract. The hormones that I prepared, let it be for the tissue culture medium, that will be 1 mg per ml. You can go to 1 gram per ml, 100 mg per ml. It all depends on the solubility of that compound. Some compound reaches saturated stage, after which how much of solvent you add will not dissolve. So that also you have to keep in mind. So this too is ideal thing. You can go 50 mg per ml, 100 mg per ml. So that is left to your convention. Now 1 mg per ml means how do you prepare the stock of 1 mg per ml? So I take 0.001. So 0.001 gram in 1 ml of water I take. So here I am taking an universal solvent, water. So whichever solvent, for example, whenever you are preparing any solvent preparation, you have to read 2-3 things from the box very carefully. You have to read. So what is its solubility? Which solvent should be used? There are so many compounds which are not soluble in water. You should use some organic solvents like or acids you need to use, or if you move to the tissue culture, hormones, phytohormones, we need to adjust the pH. So before preparing any solvent, we should not waste the compounds after adding water. If it is not soluble, it is waste. If you go for salicylic acid and all, we use ethanol, 70% ethanol. So it is better read, or if it is not given in the box, go to the website, Google, ResearchGate, and do some background study of that compound in which it is soluble. How do you store them? Should it be stored in room temperature? If you store some compounds in cold room, it gets precipitated. So where do you store them? At how many days it can be stored? It is stable. Check the stability, check the storage conditions, check the temperature conditions, and how to store them. Should you store them in an amber colored bottle or a transparent bottle? Is it light sensitive? Should you cover it with aluminum foil or kept in dark condition? So you have to do all this background study, then only you are going to prepare any solvents. So now 0.001 gram, 1 mg is nothing but 0.001 gram. If I take in 1 ml of water, that gives me 1 mg per ml concentration. Now I require volume, I require 10 ml of stock. Same concentration, I require 10 ml. So what do I take? So same concentration, I require 10 ml because I require an excess quantity. I am increasing the volume. The concentration will remain the same. This is called as the concentration. This is called as the concentration. This will remain the same. The only volume I am increasing. So if I take 10 mg in 10 ml of water, that is 0.01 gram in 10 ml of solvent I am taking. This volume is 10 ml, but the concentration still remains as 1 mg per ml. So I hope this is very clear. If I want an excess quantity, I can make it even for 50 ml I can make. Then it becomes 50 mg in 50 ml. If I want for 100 ml, 100 mg in 100 ml. So the concentration is still the same. Concentration of your stock will be still 1 mg per ml only. Only thing I am increasing the volume or increasing the quantity. So according to your how much ever you are going to use, that much you can prepare. So it is 1 ml I have to prepare, and nobody will use such low quantity. So usually we prepare 5 ml, 10 ml, hormones or 15 ml, 20 ml, you can prepare it. We can store it in the Falcon tubes or the media bottle. So this is one of the concentration for the stock that you will use. And one more thing, many people are having confusion in parts per million. So when you prepare 1 mg per ml stock, and if I want to prepare a media, 1 liter media I will prepare, and that stock of that, the concentration of that media should be 1 ppm. So 1 ppm is nothing but 1 parts per million. That means this will be having 1 mg per liter. 1 mg per liter. If I take 1 liter media and if I add 1 mg of any compound, for example, I want a media of pichloram for tissue culture which is having 1 ppm concentration. 1 ppm is nothing but 1 mg per liter. So if I am preparing 1 liter media, I will add 1 mg, that is 0.001 gram I will add. If I add that much into 1 liter media, it will give me 1 ppm solution. That if I am adding directly in the form of powder, that I will add. Now I have prepared the stock solution. From this I am going to add. How much should I take from this stock solution to add to make 1 ppm or 1 mg per liter solution? We will see. So for that we have a standard formula that we use. C1V1 is equals to C2V2. C1V1 equals to C2V2. So we consider this as a stock solution and this as the media we consider. You can interchange this. So it is ideal if you consider for all the calculation, the first part as stock and second part as the media. It becomes easier, you will not have any confusion. Moving on to the concentration. What is the concentration of your stock? It is 1 mg per ml. So you will take 1 mg. See, you require the concentration as of the media as 1 mg per liter, but your stock is having concentration 1 mg per ml. This mg in both the cases is same, but if you see the volume, this is in ml, this is in liter. So I have to reduce them. So I have to convert them into ml, or this I have to convert them into liters. So let me convert this into ml, so that will become 0.001 mg per ml. I hope you understood this. So I divided it by 1000 times, so that this so it becomes converted to 1 ml. So after this, now it takes, now this both is in same mg per ml, so I can use this formula C1 V1 equals to C2 B2. C1 is 1 mg. Volume, how much of volume from my stock I should take, that is unknown. So I will put that as X, and C2 I require this concentration 0.001 I require, and I am going to make it up to 1 liter, that is having 1000 ml. So now X will become 0.001 into 1000 ml it is going to become. So this is nothing but 1 ml. So here it becomes 1, 2, 3. So 3 0. So it is, if I do this, I will get 1 ml. So I have to take 1 ml from this stock, and I have to make it up to I will be using 1 liter media. So I will just add 1 ml of the stock solution. That is why I said we will not just require 1 ml. We prepare 10 ml, 15 ml, 20 ml. We will prepare. So I will take 1 ml from that stock, and I will add it to the media. I will get concentration of 1 ppm. I will get concentration of 1 ppm. I will get 1 ppm, parts per million, is nothing but 1 mg per liter. So you can, for further calculation, you can make this as 10 mg per ml and calculate how much should you pipette it, or you can increase this. If I want 10 ppm, how much should I take from this stock? So like this you can practice on your own. So this is the methodology that you do, and in this thing what you have to keep in mind, if you are using this formula, the formula both the sides should be similar. So if it is an mg per ml and mg per liter, convert this into mg per ml or convert this into mg per liter. So both the side it has to be similar to use this formula. And I hope this much is clear for your stock preparation. Like this, you can play around with the calculations how much ever you want. So instead of ppm, if you are using mg per liter itself, if the paper says it requires 5 mg per liter, if the paper says you require 5 mg per liter, similarly you will convert it, that becomes 0.005, this also becomes 0.005, and this becomes 5 ml of stock solution. You will pipette out 5 ml of stock solution. So if I am preparing this is 10 mg per ml, I am increasing the stock by 10 times. If I increase the stock by 10 times, this I will decrease it by 10 times. So instead of taking 5 ml, I will take 500 microliter, or 0.5 ml I will take. So I hope you understood the logic. If I am increasing the stock by 10 times, this gets reduced by 10 times. So instead of taking 5 ml, I will take 0.5 microliter or 0.5 ml I will take. Similarly, for 1 ppm, instead of taking 1 ml, I will be pipetting it 100 microliter or 0.1 ml. So that is why if you increase the stock, if you are preparing stock for 10 mg, the volume that you are going to pipette will get reduced. Or if you are decreasing this, then you have to pipette more volume. So if you are making even 100 mg, this will be decreased by 100 times. You will just take 50 microliter. So that because this is so concentrated, 100 times it is concentrated, you are decreasing this. So this is the basic thing. You can alter according to your convenience, and accordingly you will calculate. So make a calculation for first 4-5 times, then you can mind calculate it and you can play with it. It's advisable, you after making a stock, please label the stock properly, whether it is 1 mg per ml, 10 mg per ml or 50 mg per ml, and how much to pipette for 1 liter. Make a chart and stick it in your lab or in your workplace, so that you don't have to repeat calculating every time that you want to do it. Saves time also. So this is one part of the calculation that I wanted to do, stock calculation, how to prepare stock. and how do we take from this stock. Now, so this video without any editing, I'll just release it however I'm recording it. If you still feel I'm going very fast, then you can reduce the speed in the YouTube setting. It will be 1x setting. You can reduce it to 0.75 if you still feel the video is very fast. Without editing, if you still feel it is fast, you can reduce it. Okay. Now, we will go to stock calculation is over. So like this, you can prepare stock for anything you can prepare. If you are going to do any elicitation work, you will prepare, or silver nitrate, heavy metals, you can prepare the stock like this for anything, and from that you can prepare how much ever solution you require. Now, another part of calculation is using the molarity, molar, millimolar, micromolar. Similarly, that we have three calculations. Molar we represent by capital M, millimolar one small m and one big M, and micromolar one mu and one m. So this is the three calculations we'll be using: molar, millimolar, micromolar. 1 millimolar is equals to 1000 millimolar. 1 molar is equals to 1000 millimolar. 1 millimolar is equals to 1000 micromolar. So I hope the other way also you can convert it then. That means if I want to write 1 millimolar in terms of molarity, I will write 0.001 molar. 1 molar is 0.001 molar, or 1 molar is 1000 millimolar. So these are all the basic calculations which I'm not going to explain how to convert and all, to reduce the time and to save your time as well as. So this is just shifting the decimal points. That's all I am doing over here. So similarly, like this, I hope you know these conversions and calculations part. Okay, now if I want to prepare, for example, let me take silver nitrate. So if I want to prepare the silver nitrate solution, 1 molar or 10 millimolar or 1 micromolar solution, any solution like that, I want to prepare silver nitrate. One random example I have taken, the silver nitrate. In that bottle of silver nitrate, they will be specifying the molecular weight of that compound. So whatever now I am going to explain, these are all solid compounds. It is very simple compared to your liquid compounds. That is why I made that as second part of the video. Now we are going to take silver nitrate. The molecular weight is 169.87 grams per mole. So here I am not going to explain what does this gram per mole means, or what is the theoretical part of molecular weight. All those things I am not going to explain, because it's all comes under a chemistry, Avogadro's number, molecular mass, so many things are there for if I want you to understand what is molecular weight, gram per mole and all. So here only the calculations I will be concentrating, theoretical concepts you are not going. So this will be given in your bottle itself, or this will be available even in the internet. So it is advisable to see the bottle that you are buying, because if you go for some other compounds, the molecular weight varies. If you go for one example is when you are preparing the phosphate buffer, you will use monosodium for sodium phosphate, basic and all, based on the number of hydrogen atoms. If it is an hexahydrate, heptahydrate, so it varies. So you cannot take the molecular weight from the internet, and if you are using heptahydrate, you cannot take the decahydrate molecular weight. So whatever compound you are using, take that chemical box. In that description it will be given, or using the formula whatever is given, go back to the Google and cross check it. So it is advisable to take the compound, that the box in which it has come, it will be mentioned. All the boxes will be mentioned in the description. So you can take that and use it. So the molecular weight of silver nitrate is 169.87 grams per molar. It is very simple. If I take this 169.87 grams in 1 liter, that is nothing but 1000 ml. If I take this much amount, that is 169.87 grams in 1 liter, that gives me 1 molar solution. That gives me 1 molar solution. Now for example, I want to prepare. Here also we need to prepare the stock solution, then it is becoming simple when you are going to take different concentration. If you have only one concentration, now for example I want to prepare 50 millimolar, let me think. I want a solution of silver nitrate 50 millimolar. So if I take 169.87 grams in 1000 ml, that gives me 1 molar solution. So now I want 15 millimolar solution for 100 ml I want, or 10 ml like that you want. Similarly, so if I 50 millimolar, so if I take, say I'm just shifting 1 point over here. So if I shift this 3 times, that gets converted to 1 millimolar, that is 1, 2, 3. If I take 0.169 grams in 1000 ml, that gives me 1 millimolar solution. It is very simple. This is your actual. If I take 169.87 grams in 1000 ml, it gives me 1 molar. 1 molar and 1 millimolar, what is the difference? I said you 1000 times if I decrease it, 1 molar will become 1 millimolar. This I am dividing it by 1000. If I divide 169.87 divided by 1000, I get 0.169 gram. So 0.169 gram if I take in 1000 ml, that gives me 1 millimolar solution. Now I want 50 millimolar solution. So what I do? I multiply by 50. So this into 50 if I do. So 0.169 into 50. So this into 50 I am going to do. That will give me 0.169 into 50. So if I take 8.45 grams, let me cross check again. 0.169 into 50. Yes. So if I take 8.45 grams in 1000 ml, that is going to give me 50 millimolar solution. But I require only 100 ml. So if I am reducing 1 0 from here, so I have to increase the decimal point, move towards the left hand side. So it becomes 0.845 grams in 100 ml will give me 50 millimolar solution. This is for 100 ml. If I want for 10 ml, again another 0 I am going to add, moving the decimal towards the left hand side. 0.084 grams in 10 ml will give me 50 millimolar solution. So it is just moving the decimal point. So it is very simple. So just calculate like this, and it will require time. Initially when you are calculating, it will take time. Later it becomes very easy. So now let me give another example. If I am going to prepare the stock solution, and from the stock if I am going to prepare, how do we calculate? Let me explain you that. So same example I will consider. So same example, and same I am going to take 100 ml only as the volume. So 100 ml only I want. Now let me prepare a stock solution. So similarly the stock solution, it will vary. Either if I take 169.87 grams in 1000 ml, that will give me 1 molar solution. So if I want to prepare 10 ml solution, if I take 16.98 grams in 100 ml, this will also give me 1 molar solution. I am just shifting the point towards left hand side and cutting a 0 over here. If I take 1.69 grams in 10 ml of solvent, silver nitrate is soluble in water. So if I take 1.69 grams in 10 ml of water, that will give me a stock solution of 1 molar solution. Unlike the hormones or whatever, there we expressed that as mg per ml or 10 mg, 1 mg, gram per ml, like that we expressed over there. Here we are expressing in terms of 1 molar solution. So this gives me a stock of 1 molar solution stock. I can prepare 100 micromolar stock or 100 millimolar stock. So how much ever, if I have 100, if I am going to prepare Same volume, if I'm going to prepare, if I take, this is 1 molar, if I take 0.169 grams for 10 ml, see I have reduced it 10, so this becomes a stock solution of 0.1 molar. 0.1 molar, or this becomes the stock of 100 millimolar. So if I take 0.169, the stock becomes 100 millimolar or it becomes 0.1 molar. So either you can, since it is silver nitrate, it is very costly, we use less stock concentration. We never prepare stock of 1 molar, 10 molar and all. So we can prepare. So if you are going to use any other compound which is easily available or you require a higher concentration, definitely we can prepare 10 molar solution, 100 molar solution. If the solubility is possible, then you can prepare such type of solutions also. Now, so I am going to prepare 0.1 molar solution. I have taken 0.169 grams in 10 ml of dissolved water. Always we will make it up. So what do I mean by making it up? If I want to prepare this stock solution, I will weigh 0.169 gram. I will transfer them into a glass beaker or anything. I will add first 2 or 3 ml of solvent and I will dissolve it. 2 ml or 5 ml or 6 ml. We do not add 10 ml at once. We add 6 ml or 5 ml. We dissolve it well. Then we transfer that into a measuring cylinder, 10 ml measuring cylinder, and we make up it up to 10 ml. Don't add 10 ml directly. So we will always make up. That is all basic things whenever you are calculating. This is where the error comes. Calculating standard graph and all, you do not get 0.99, 0.98. These are all small techniques which will give you larger error. So always you will make up the volume. Let it be anything, you will make up the volume. Okay. Now, this is my stock that I am going to prepare. I am prepared a stock of 100 millimolar or 0.1 molar I prepared. Now I want a solution of 50 millimolar for 100 ml I want. So we will use the same formula, standard formula. C1V1 is equals to C2V2. C1V1 is of the stock, C2V2 of the solution that I want. The concentration of the stock is in millimolar. The concentration here also is millimolar. So there is no conversion. I can easily proceed. C1 concentration of stock is 100 millimolar. Volume, how much from the stock should I take to make up this? That I don't know. That is X is equals to C2. Concentration is 50 millimolar. And volume I know is 100 ml. 100 ml. So if I take X is equals to 50 into 100 divided by 100. 100 gets cancelled. So X becomes 50 ml. So I have to take 50 ml of stock. I have only 10 ml. I can make it up to 50 ml. Into 5 I will do. This also into 5 I will do. I can make this up to 100 ml also. Volume I can increase, like how I explained you in the first part of the video. Volume I can increase. So I will take 50 ml of stock and I will add 50 ml of water itself to get this solution of silver nitrate. So now if I want lesser stock, let me take an example of 100 micromolar. If I want 100 micromolar, if I want 100 micromolar, how do I calculate it? So if I want it for, let me say example for 100 ml only, let me keep it 100 ml, I want 100 micromolar. So C1V1, you see it is in millimolar, C2V2 is in micromolar. So this is in milli, this is in micro. I have to convert any one so that both becomes equal. So if I convert 100 micromolar into millimolar, it will come as, so 100 divided by 1000. So just to cross check, I am using calculators. So it is 0.1 millimolar. 100 micromolar is nothing but 0.1 millimolar. So C1 V1 of stock is 100. I will put here. V1 I don't know X. C2 is 0.1 and V2 is 100 ml. 100 ml. x is equals to 0.1 into 100 divided by 100. So I will take 0.1 ml. Since all these are in ml, this is also in ml only. So I will take just 0.1 ml. That is nothing but 0.1 ml is nothing but 100 microliters. So I will just take 100 microliters and I will make it up to 100 ml using water. So I will add 0.1 of stock, 0.1 ml of stock and 99.9 ml of water I will add to get an 100 ml solution of 100 micromolar concentration. So I hope this video is clear. So if there are, I think there is no any concentration, everything is correct, there is no calculation error I feel. Yes, it is correct. So I will take 100 microliter or 0.1 ml to get it. So like this you can calculate whatever you require, you can calculate it. I will just explain one smaller another calculation in this video and I will end here. So here percentage calculation also let me take. Now if I want to calculate percentage that everybody will be knowing, but still if anybody feels if they require it in depth, so let me take that also. Now in one assay, for example, if I am not wrong, we will use 96% sulfuric acid in the carbohydrate phenol sulfuric acid method of carbohydrate. There we will be using 96% sulfuric acid. So if I want to prepare anything in percentage, it is very simple. So if I want to prepare 96% of sulfuric acid H2SO4, I will take the bottle. If the bottle is having 100% sulfuric acid, or if I let me consider 96% of HCl I want, then whatever the bottle I am having, right, I will add 96 ml of sulfuric acid plus 4 ml of water. Similarly, if I want 20% HCl, or let me take some example of salicylic acid. Let me take 10% salicylic acid I want. If I want 10% of salicylic acid, I will dissolve 10 grams in 100 ml. Here everything is for 100 ml because percentage means it is for 100. So if I want a 10% solution, I will take 10 grams, or if it is liquid, I will take 10 ml and I will add 90 ml of water. There if it is a liquid, you are not supposed to add 100 ml of water. If it is a liquid, you will add so that much to make it up to 100. That is why I always say make it up I say. If it is a liquid, for example, if I want to prepare 10% methyl jasmonate, methyl jasmonate comes in liquid form. So if I want to prepare 10% of methyl jasmonate, I take 10 ml of methyl jasmonate, I add 90 ml of water, or I am using any solvent. Methyl jasmonate, if it is insoluble in water, I will use methanol. So I will make, using methanol, I will make it up to 100 ml. That gives me 10% of that particular compound. Here if it is in grams, if it is solid, if I want 10% salicylic acid, I take 10 grams, I weigh 10 grams and then I dissolve it with 10 or 20 ml of water and then I make it up to 100 ml. Same here also, the water is not the solvent, I am just giving water as an example. Since it is a universal solvent, you have to study which is the solvent that is soluble for that particular compound. Using that solvent, you are going to make it up to 100 ml. So this is the percentage calculation. So this covers almost a major part of the calculation, molarity, and in case of solid, molarity and normality both remains the same. So I have calculated the molarity. For normality also it remains the same. But in case of liquid, the molarity and normality changes. So I will say you that in the second part of this video. So in this we finished the parts per million and mg per liter, mg per ml. That calculation for the tissue culture is mainly used, hormones and all those things. Then we moved on to the molar, millimolar, micromolar and all we used. And then we went for the percentage calculation. So if this video was useful, if you feel this video will be useful for your friends or your classmates, please do share it along with your friends and in the groups. And also to subscribe, stay subscribed to my channel. Stay tuned for the second part of this video. Thank you.